Ladies and gentlemen, my friend, George Bjelovuk.
It's really a privilege for me to be here tonight. Andres, I appreciate the invitation, and like Andres mentioned, he took away like the first 5 minutes of my remarks. We've known each other for a long time. When he was with Austin and I was with AEP and Mike was with Excel, a lot of us in this room, frankly, have been involved in this smart grid discussion for a long time. But when he called me and talked about this conference, this inaugural event for the Digital 360 Summit, he really wanted to tee up a set of topics that we're going to talk about tomorrow, and I wanted to just throw some provocative stuff out tonight to at least get some folks thinking about what we're really talking about when we talk about transformation of the energy industry and what we're likely going to see over the next few years. So I just challenge the room to, when we talk about digitalization, I'll ask you this question: are you ready? And hopefully by the time we get through this presentation and you get through your sessions tomorrow, you'll have a chance to assess yourselves on whether or not we're ready to enter this new digital age that we're going to be talking about. So we've heard these three words a lot, right? Decarbonization, decentralization, and digitalization. And whether you follow the global warming thing or not, I think we're all focused on climate change. I've got 3 adult sons. We have lots of conversations like this around the Thanksgiving table about what climate change means to them, their children, and future societies. And I think we're seeing the emergence of lots of opportunities for generation to exist in non-traditional forms at the edges of the grid, taking advantage of heat recovery systems, renewable energy, those things that allow us to generate electricity in non-traditional places. And that creates a whole new set of challenges for utility operators and us as consumers about the transient nature of these sources of generation. Another global megatrend that we see around the world is urbanization. We see people moving into the cities. Our cities are getting bigger, and the urbanization trend is going to lead to we believe it's going to lead to the desire to have much more resilient electric systems. So an urban area that's not dependent on some centralized faraway generating system that has to flow through transmission over hundreds of miles, but a local generating facility that can enable us to recover ourselves. And if you think about the impact that Hurricane Maria had on the island of Puerto Rico, Siemens had the privilege to help the government there really rethink how they put their system back together. And I spoke at a conference last week where most of the audience felt the utility grid in the United States was going to become irrelevant. And so I had to spin the tape back to Edison's Pearl Street station and said, remember this thing? It was like kind of a microgrid, and it didn't really go very far because it was DC, and it took a couple of guys like Tesla and Westinghouse to say, well, now we can go a little farther distance. And they integrated the systems to one another with high voltage transmission lines, and spend the decades forward. We figured out ways to make bigger centralized units and higher voltage transmission, and we enjoy the benefits of high reliability and resiliency from an interconnected grid. So go to the island of Puerto Rico for a second, where Hurricane Maria comes through and completely wipes the island clean. Like the entire island is in the dark. And think of the unique opportunity that you have globally to say, let's take today's technology and rebuild the electric system for the island of Puerto Rico. And so what happened was they essentially built 10 mini grids around the island, leveraging the oil, gas, coal, wind, solar, all the generating sources that existed, and stood them up in 10 mini grids that operate independently of one another, and did it from a perspective that we'd like to be able to bring those systems back independently of one another, in isolation of one another, so that when those long-distance transmission lines came back to service, we could essentially recouple the network and enjoy the benefits of an integrated system while still enjoying the resiliency and fast recovery times of microgrids and mini-grids. And so I think this whole decentralized world, I think, is something that we should all be paying attention to because it's happening all around us. And finally, the digitalization, right? So the theme for this conference is really we're going to spend a lot of time talking about what that really means to us as utility operators, as software providers, as vendors in this space. What does digitalization really mean for our industry? Andres wants to tee up this concept of new market models and new utility roles, and he's smiling right now because the second one up there is transactive energy, and he knows that some of the conversations we had 15 years ago about what we collectively thought, in the utility industry at least, thought about what transactive energy is. But today, we're seeing a whole new set of business models emerge. So a developer develops a piece of property, decides that there's going to be office buildings on that land that need steam, that need chilled water, that need electricity. So why not provide all those services in the absence of a utility? Why not provide all those services to a campus that has a single delivery point to the utility that serves that property, and a new entity emerges as an energy as a service provider to that campus of office buildings, industries, maybe residential homes. So I think we're seeing the emergence of this new business model called energy as a service. Transactive energy, for those of you who don't know, 15 years ago, there's been a lot of folks sort of postulating on the future that allows Andres and I to be neighbors of one another, and him to have solar panels on his roof and me to not have any, and he's got some excess generation on his house. He could sell it to me during the day, and we just have some bilateral transaction between the two of us that doesn't really involve anyone else. And so we've got to have a whole new set of protocols that emerge to enable this transactive energy future, right? And in distributed markets, so I'll use Puerto Rico as another example. So today the island of Puerto Rico is a single economic market, but those 10 mini grids that we created as a result of the reconstruction can actually independently operate of one another. And if we had the ability to create the transparency of pricing signals in those 10 markets, think of the power that you'd have to say, okay, you're in this market, and right now our source of generation is solar and storage. It's driven, the price per kilowatt hour or the demand charge is driven by those assets, where the folks on the other side of the island are fueled by an oil plant that has to have oil transported in by barge, and so their prices might be significantly higher than yours. And it's not until we achieve the interconnection of the systems that we can all enjoy the economies of scale of an interconnected utility network. So think of the implications of a fully transparent distributed marketplace. And then, so what's the role of the utility? And I suspect tomorrow a couple of panels will be talking about this. So are they a platform optimizer? Are they a service provider? Here in Texas, the regulations essentially made the electric utilities all TDSPs, right? Transmission and distribution service providers. And the generation providers and the folks that own the customer relationship are a really different set of entities. So interesting evolution. I'll say this slide we've animated and really suggests that these two things are they're connected to one another, right? So the presence and expansion of distributed energy systems and the need for digitalization really feeds one into the other. And I think as we move forward through this presentation and your conversations tomorrow, we expect that hopefully when you leave tomorrow afternoon, you'll understand my job is to keep everyone from falling asleep after eating that big piece of beef. So I might actually have to stop in the middle and tell a few jokes. So everyone saw the left side of this stage, left side of the slide, and the right side of the slide, right? So that we're moving from a traditional energy value chain where the utility operated in this paternal role, right? The customer was considered a class. The utility and its regulator was really considered as the entities that really looked out for the best interest of the customers. They went through integrated resource planning. They found the most cost-effective way to generate electricity, went through due process and prudency reviews, and ultimately the paternal nature of the utility is kind of what's on the left side of this equation. And on the right side of this slide is this whole new distributed energy world where we're going to see more and more entities emerge on the right side of this page that are going to generate electricity in some distributed manner, energy as a service that we talked about earlier. And what enables this transformation is digitalization. And I commend Andres for using this as the keynote or the theme throughout the conversations tomorrow, digitalization. So one thing I'd like to spend a minute or two talking about is, so what's the role of the grid? I was in Indiana last week when folks thought the grid was irrelevant, and I had a chance to dispel some of those perspectives, hopefully. But I'll just tee up three things. So one role for the grid is going to have to be to manage these intelligent devices. You know, we can't have a grid with all these new points of interconnectivity without some way to manage these devices and authorize them, register them, really understand their role to one another. We can't have, and you know, people talk about blockchain and all these cool ways we're going to get this done. At the end of the day, managing intelligent devices and as they interconnect to the grid is going to be a key part of this data-driven grid operation. The second one is managing distributed assets and managing them in a way that, if you think about how power generation works in the United States today, we've created regional transmission organizations, and our RTOs basically set markets, wholesale markets for generation and capacity and load, and those markets are managed in a way that allows generation to get bid, load to get bid. We'll get John Wellinghoff here. He's gonna check me on whether or not I'm articulating these points correctly. So I'll defer that to the former FERC commissioner. But the point is that when we've got many new sources of generation, how those sources of generation interact with load and how they interact with one another will become a key part of what we're going to need to manage. And then finally, using data to improve the ability for the grid to be more stable, the grid operations, I think is going to be a key attribute. So we've spent some time, we at Siemens have spent some time on this picture. And that is, if you look at the left side of this device, or left side of this picture, you see all these new devices, smart meters, intelligent energy devices, RTUs, sensors, all these things that are being introduced into the marketplace. And the presence of high bandwidth communications, so things like fiber, 5G cellular, we've got lots of cool things that are going on in the comm space right now. There's this deluge of data that's headed toward the utilities and these enterprise systems on the right side of that picture, right? So things like our CIS systems, our asset management systems, our outage management systems are about to get drowned by all this data and all this communication capability that exists. And frankly, what we decided is needed is some kind of an integration platform in the middle, some way for us to create as an industry to create some transparency into what's really happening between the devices on the left and those enterprise systems on the right. And how do we create a new ecosystem for new entrants in this space to actually get in this business? And so I'll say the Siemens realization, I'd like to position us as being one of the leaders in this space. We've thought about an entirely new way to think about this. And what will this application system, I am going to fall off this stage. What will this application ecosystem look like? And so if you think about the drivers, so there's been forecasts that suggest that we're going to see over 500 million smart meters by 2025. And if you think about behind the meter endpoints for a second, so if your home was a smart home, you might have a Nest thermostat, you might have a handful of sort of smart devices that are kind of connected to your energy system. If you're like Andres's house, it might have a Control4 system that's got a bunch of AV stuff connected to it that you can connect remotely, right? But, let's call it maybe 8 or 10 devices, right? But put yourself in the mindset of a factory or a campus. There could be hundreds of thousands of connected devices behind that single meter. So think of tens of thousands or hundreds of thousands of devices behind every meter, and now 500 million meters. And someone do the math on that for a second. You realize very quickly that we are orders of magnitude farther than anything that we've ever had to manage, not in any industry. Whether it's banking or retail or insurance or pick an industry, we're talking about real-time data and intervals of data that span from as few as 15-minute intervals down to 3 to 5 second intervals. We're about to get drowned in data. So digitalization is going to require a whole new set of thinking, I think, from all the folks in this room about how we're going to actually manage this future. So, I thought about bringing the OSI 7-layer stack in here. He's laughing. But I decided there's a different way to actually articulate this point. And one is this: think about this architecture as a set of portfolio elements for any software company. So at the bottom, you've got the connectivity and message routing required from an operating system standpoint or platform as a service. And as you move up the stack, so the first thing we talked about is how do you manage and register all these devices, hundreds of millions of devices that are going to be on this network. And I think we've got to get past the point that there's going to be a central repository for this stuff. There's got to be a way that we can distribute that responsibility so that maybe there's a registrar in Columbus, Ohio that's different from the registrar in Austin, Ohio. And beside them being UT fans and Buckeye fans, they've got the responsibility to make sure that the pieces and parts of this puzzle are actually authorized to be there. And we basically broker some kind of interactions between us that we haven't yet thought about. The data management and storage, you can work your way up the stack. I won't read the slide, but at the end of the day, we think there's a whole new set of application elements and a whole new ecosystem that needs to get developed. And so, this slide that's on the right, if you think back to I apologize for the size of my circles, right? But back in 1992, that's a computer, right? That's a PC back here. And how many data points, how many of those things we think we had in business in 1992? And if you whip your way through that little exponential curve, you'll see that almost every 6 months there's an adoption of another new technology. If it's smart thermostats, if it's iPads, if it's some other mobile devices, we're going to have, these devices are exponentially increasing in scale, and to the point now where we think there will be 50 billion connected devices globally by 2020. Just think about the number, think about the magnitude of that number for a second. 5.5 million devices get connected every day. Every day there's 5.5 million new endpoints getting introduced into this ecosystem. And someone jokingly suggested that half of the data that we have today that we manage got created last year. So you want to know how steep this exponential curve is. Half of what we're managing wasn't here last year. But the punchline, I should make that little thing in the lower part of that slide, half of the data that we've collected and that we're managing isn't used for anything. We're not using it for analysis. We're not using it to make any decisions. It's just stacking up the storage in our buildings and our data centers. And so the global data volume and this exponential hockey stick, I think, is one of the things that we all need to be aware of. So I'm going to finish my remarks tonight with this new ecosystem of applications that I think Andres and this organization, I think, is about to challenge all of you, is to think about how does this application environment, how do we manage this immense amount of data with digitalization? What's going to be required to get that accomplished? And I'll start at the bottom and work my way up. So the first thing is we've got to have standardized ways for these devices to connect to one another. We joked at the table today, we can't have line voltage sensors provided by a company that only allows its line voltage sensors to be communicated with its sort of communications device, right? And so we've got to figure out a way for those devices to all coexist with one another. And so that means new standards, open standards like OPC UA or others that allow these devices to coexist in an ecosystem and allows software developers, not just Siemens, but the entire ecosystem of innovators that are in this space to think about ways to communicate with these assets that are out on our systems. In the middle is this high-capacity computing environments. So think about the implications of managing and making decisions, computing decisions around 500 million assets. I mean, no industry has ever had to do that before. And I think this industry will be challenged to take the best parts of what we've done with cloud computing, what we've done with machine learning, and figure out ways to move that computational horsepower to different places in the network. With this business of we've got to bring everything to some central brain to decide what to do and then send a decision back out to the edge, I think is going to go away. I think what we're going to see happen is decisions are going to get made locally, decisions are going to get made centrally, and somehow those sets of decisions are architected and orchestrated in a way that bad things don't happen. And we've got to figure out how that's going to work. And so this high-capacity platform that's in the middle, I think, has to leverage the best of cloud computing and the best of the capabilities that we've had in this space. And finally, the top, so open application development. What does that mean, right? So if anybody's got an iPhone in here, there's who knows how many new iPhone apps come out every day, right? And so there's an ecosystem around how do you develop an iPhone app? There's a standard application development language, there's a developer's kit, there's a process you need to go through to make sure your application doesn't introduce vulnerabilities and doesn't introduce Trojan horses to my cell phone. But at the end of the day, it's an ecosystem that's fully transparent. It allows developers to see completely into what's going on in those lower levels and allows developers to think about a business case and a value proposition for customers that those of us that have been in the utility industry for 20 years haven't thought about that yet. And so I think the challenge is for us to figure out a way to create this transparency to those devices, enable this high-capacity platform, and ultimately enable a whole new generation of software developers and innovators to take us to the next level in the energy industry. I'll amplify that point with this slide and say, so think about how applications have historically been built. I don't want to get too geeky on everybody. So think about how applications have historically been built. We've had an asset management app, we've had an outage management app, we've had a customer information system. But if you actually boiled those applications down, there are certain common elements across all those applications that aren't necessarily unique. They're almost like utilities, right? So those little blocks that are up there suggest that there's some interoperability even in the application level that we could start taking advantage of. And so if you started at the top and said, if I built a set of applications that were modular, and I could take a module from this application and a module from that application and stitch them together to create some new application, we think it's going to be the next generation of how software gets introduced in this business. This concept of creating a big monolithic application that does soup to nuts, and then another big monolithic application that does some other soup to nuts, and then have to figure out how you integrate those applications. Those days are gone. I think what we're about to see in this industry, and I'd like to believe my company is leading this effort, is this concept of modular application design and allowing applications to get built from the ground up, basically deploying sets of functionality that are required and then amplifying those and augmenting those as requirements are necessary. So here's another example of application modularity. So we take the distribution system operator may have a set of applications that involve meter data management systems, virtual power plants. A retail provider might have a set of applications that are different from the distribution system operator, and the market operator might have a different set of applications yet. But all three of those entities, even though they're in completely different business, have some common elements in their application portfolio that they can leverage from one another. And what's at the core of that is this high capacity capability to transmit and manipulate all this data and supply those applications to meet the requirements of the business. We've actually embraced this decarbonized, decentralized, and this digitalized future of the industry, and we really think that the future involves a brand new entity called prosumers. And if you haven't heard that word yet, you're going to hear it a lot. If you don't hear it tomorrow, you're going to hear it a lot over the next few quarters. And that's, consumers of energy have become producers of energy. This concept of you're a customer or you're a generator is gone. I mean, those concepts have now become blurred, and this new term, prosumer, and the prosumer-centric energy world is something that we all have to focus our thoughts and minds around how we actually serve this industry. And we've basically, if you look at our application portfolio, we've thought about traditional utility services and serving those entities that aren't utilities, campuses, new entrants in this business, and we believe our portfolio has actually leveraged the best features and functions of this. And finally, if you take our application portfolio from grid planning and simulation to grid operation to analytics, and use our MindSphere application, which is our trademark for this high capacity network that's in the middle of this whole world, I think you realize that I think we're all collectively moving forward in this space, and I'm excited about what the future holds for us. So Andres, thanks again for the opportunity to deliver this keynote, and I wish you great success and dialogue in your discussions tomorrow. So thanks a lot.